And we are ready to go. So 109. 109, here's a question. I think we got a couple of questions. Let me do it by subject. And I got to find them after I do the subject. There we go. All right, we got two questions. One is 1.2, and again, it looks like they're the same questions. I don't know. This is 1.2, 1.211, and this is, what does it say? Graph equations. I don't care about that. And here's the question, if it ever comes up. Hopefully it will come up. There it is. Is this a test question? Yes. Now they give you a problem. They say graph it. So we're going to take our handy dandy whiteboard and I'm going to write down the problem. Y is equal x cubed plus 3. Now, there's 2 or 3 things I'm going to kind of review over right now. And one thing is there's 2 ways to graph this problem. There were 3 ways if you use the calculator, but we're not using the calculator because we want to depend on our brains. So, one way is plotting points. Second way is family of graphs. And the third way is by your calculator. Now, I will tell students that if you own a Droid phone, you can go to Wabbit, EMU, and you can download a TI-84 on your Droid phone, free. If you have an Apple, I think you have to go to online calculator, I think, somewhere like that. Apple, you have to do online calculator. I can't remember exactly. And you can download one. There is somewhere online for Apples that you can download free, but I don't know what it is. You might be able to find it. If anybody finds it, let me know or type it in the conversation so other people will know. But you can download a TI-84, and that's about the best one, 84 CE or something like that. For if you don't want to have to go out and buy one, you don't need to. Now, calculus, you might need one if you can't use. If you got a good phone, you know, mine's a pretty good one. I just got a S9 Plus. I mean, I can actually do all my calculations with my TI. I mean, I'm trying to find it. I don't know where I got it right now, but where's the T's? T's. Well, somewhere it's in there. I got it somewhere. I can't find it right now. It may be under Wabbit. Well, I was going to show it to you, but I can't find it. So if I find it, I'll. But anyway, if you've got a big screen or a somewhat big screen, you can use the Wabbit EMU or the. I'm just trying to see why I can't find my. Let me just type it in. Wabbit. There it is. And there is my TI. And I got an 84 plus C. And you can use it accordingly. and works just as good. You're welcome. All right, so let's talk about the 3 ways, and this is kind of a review because I'm going to review over family of graphs. In fact, I'm going to go ahead and send that to you right now through the handy dandy chat section. And let's see if I can find it right quick for you. Graphs, GRAPH. And let's see, where are they? Downloads. There should be a family of graphs somewhere. Oh, well, I'm not going to look for them right now. I'll just pull it off the internet and send it to you. Only take me a few seconds. And that way you can put it, well, let's say there's 23 people in here for the 5 that are going to print this out for you. I usually use this one. So copy, Word. Yeah, this is a lot of work, and I know some of y'all can't, handle a lot of work, so I'll just do it for you. Layout, orientation, landscape, margins, none, and Control V. Yeah, it's a lot of work, isn't it? So let me spread this out a little bit more. There we go. That's good enough. Let's see. Move it up. Now I can't get it to fit any better, so that's good enough for government work. And you can fix it better if you want to. So I'm going to save this as parent graphs. Parent graphs. That's under documents. And I'm going to send that to y'all. You're welcome. Hold on just a second and I'll send it. And I left it in the word processor so you could actually edit it however you want to for the 5 that are going to actually print it out. All right, so there's your parent graphs. And what I mean, well, you need to memorize these parent graphs. You need to memorize them. What do you mean memorize them? Well, one, you need to actually print them out, and you need to memorize them as far as what they look like. This is a cubic function, so this function is going to look like this, and you can actually graph it by the family of graphs by going over to the parent graphs and saying, well, we know this is the vertical shift or the y-intercept. So 1, 2, 3, and it looks like that. So this is called sketching. Okay, that's sketching. Of course, it looks better if you have a full page. 1, 2, 3. There we go. So that would be how you would sketch it. And then, of course, plotting points. X cubed plus 3. Whenever I plot points, I use the same points, -2, -1, 0, 1, and 2. -2 to the 3rd power is -8. -8 plus 3 is -6. -1 to the 3rd power is -1 plus 3 is 2. 0 plus 3 is 3. That's your y-intercept. 1 plus 3 is 4. 2 is 8 plus 3 is 11. So -2, -6. -1, +2. 1 and 4. 2 and 11. And that's how you do it by hand. So you got a sketch, you got a plot, and now let's go to the handy dandy calculator. Handy dandy calculator. It'll take a second for mine to pull up, because it actually has to go to the TI website or server or whatever. So hold on, let it pull up. I usually have it pulled up before, but sometimes I accidentally exit out of it, and that's what I did in the last class. So here we go. Y is equal, clear. Well, I'll use that x cubed. So I just need to delete the rest of this. I will never understand the delete process on this calculator. You hit delete and it jumps up to the previous. I don't understand that. If you go slow, there we go. +3. And graph. There you go. Hold on just a second. Let me take that x is equal to, let's clear that. Sorry. Clear. Clear. There we go. And let's do a zoom standard. There you go. So however you want to graph it, the chances are, since this is a homework problem and they want you to graph it, then I would do plotting points. And I would plot, you know, some of these points right here. I don't know how many they want. So let's go and look and see. Well, where's the problem? Sorry. There we go. So -3, I got what? Well, I didn't do -3. So -3 is -27 plus 3 is -24. That's good. -5, -2 is -6. And I can't change it. So anyway, that's where you went wrong on that one. -1 is 2. 0 is 3. 1 is 4. 2 is 11. It looks like you just, let's see, that'd be 20. Yeah, you just messed up 1. I'm going to make sure I didn't mess it up. Let's see, -2. Yeah, I did. -2 is -8 is -5. So I did mess it up. I suck. There we go. All right, I just changed that to -5 right there. So you should have got that right, unless you don't know how to graph it. And here's how you graph it. You pick a cubic function. There's a cubic root right there. And you just pick 3 points. I'm going to pick -2, -5, 0, 3. And what's the other one? 2 and 11. 2. Okay, it's not supposed to do that.
You have a work email.
Let me hit it again. It would help if I could see everything. There we go. All right, so I want to do a cubic function. I hit cube. And -2, -5. There's a point. And then 0 and 3 should be my next point. I don't know why it's not doing a cubic function. So I have no idea why it's not doing a cubic. Okay, 4 point. I got to give it 4 points. Okay, so 1 and 4. I'm going to do 1 and 4. Is that 1 and 4? And then a 4. There we go. And then a 2 and 11. There we go. And that's how you graph it. And they want you to graph it on the calculator, which looks nothing like ours. But we know it's going left to right up. So it's either B or D. This one is not, that's a negative y-intercept. This is a positive y-intercept, so it's delta. I hope that helps. And remember, I was trying to get 3 things in instead of 1. So that's why I kind of went around the world. I kind of got a review section in with 1 homework question. Anybody got a question on that? And why are they harping on graphing? I mean, watch a Beautiful Mind. John Nash, economics, that's all you do. You draw graphs. So if you're going into marketing, economics, or business, you're going to be drawing a lot of graphs. So next question. Next question in the emails is, and somebody done sent another question, thank you. 1.2, I'll get rid of that one. This is 1.2, and I don't see anything else. Number 11. I have no idea how to do this problem. And I might not either. It might be one of them bad problems. Watch the video. The number of students, blah, 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 I can't even pronounce that, can be described as, okay, they give you a function. So the first thing you do as a student is you write that function down. So they're going to ask you to graph it or plot points or something. So S is equal to 0.028 t squared minus 4.91 t plus 228.73. Now, I am pretty much hardcore, you know, using math, I forgot to turn on my video, I'm sorry. I'm pretty much hardcore on using math and not using your calculator, but this right here is nothing but the calculator, all right, or computer. So first of all, you need to type this in to your calculator, and remember that t is equal to the number of years after 1990. And I'm going to highlight that because you have got to remember that. After 1990. So before I even do anything with this problem, I'm going to graph it. So I'm going to go to my handy dandy calculator and I'm going to graph this function. Y is equal to, and I'm going to clear all this. Clearing it is better than trying to type over it, so make sure you clear it. 0.028 x squared minus 4.91x plus 228.73. And there's what the graph looks like. Oh my God, there's not a graph. So you quit and drop out of the class. No, you hit Zoom and try standard first. Zoom standard is 6. Still don't get anything. Try Zoom fit. Zoom fit is 0. Okay, we're starting to get something now. So I'm going to zoom out. And I'm going to put the center of the graph somewhere over here. Up, starting to get a little bit more. Zoom out. Oh, me. I'm sorry. When you're working a calculator with a mouse, it sucks. Sorry. And you should be able to see it now. And there it is. Now, if you want to play with it some more, then zoom out one more time and put it right about there, and you should be able to see a good, there you go. Now you can zoom box, and I'm going to just zoom in on like an area, like you can pick what you want. Make a box. Now this is what I do, and I teach students how to use the zoom box, because to me it's easier than using the window. And you got to type in numbers and go look at the graph. Type in numbers, go look at the graph. So that's why I use zoom box, because you don't have to do that. And enter. And now I can see the graph. So now, pretty much, let me show you another feature on the calculator. Up here, you see the blue numbers above are blue letters. You want to hit table. So, table. And there's your X and Y values. Go to 0 because 0 should be the y-intercept. And there's 0. 0 should be 228.73. Yep. And everything from there is pretty much in the first quadrant. So now let's go see what they're asking for. Now, what did we just do? Okay, what did we just do? We graphed and we got familiar with the zoom feature on the calculator. And we also got acquainted with the table. And that's what these are. These are calculator drills. These are drills for your calculator. Make sure you know how to use a calculator. This problem is 100% calculator problem. It says use the graphing utility to graph the function on the viewing window. Now, I'll show you how to use the window, but I don't use it. So I'm going to show you how to use it. Right here, there's the window. You click on window and you type in those numbers that they gave you. So they give you the y min is the x min is 0 to 17. So you would type in a 0 right here. You would type in 0 right there and 17 right there. And then on the y is 0 to 300. So you would type in 0 and 300. And then you would hit graph, and that's all you would see. So you can see why I use what I use. I use the zoom window and the zoom box. I'm sorry, zoom box and zoom out or zoom out and zoom box, whichever one you want to call it. And I get to see the whole thing. So I'm going to do it one more time so you can see how I did it. I'm going to zoom out. And I'm just going to do zoom out there. There. I'm going to zoom out again. We'll move over here and hit enter. And zoom out one more time. And move it right over here. Okay, now I'm going to go to zoom box. And this is how I do it. And then I'm going to get a nice section, usually including the Y and X intercepts. And enter. My first one was a whole lot better, so I'm going to redo it. Zoom 6, zoom 0, and that zoom out. I thought mine was a whole lot better to see it, so I'm going back and doing it. Zoom out. And I'm not wasting time because some of you are going, okay, and what do you hit? What do you hit? And that's a good thing. Not knowing how to use your calculator is a good thing. It's a whole lot better than some of these characters that can take their calculator and spin it around their finger like a basketball. Those are the ones that'll have bridges fall because they depend on the calculator too much and they don't think. So let's do a zoom box. And I'm going to include the y-intercept. Enter. And I'm going to include a little bit past the x-intercept. And again, to me, that looks a whole lot better than what we were dealing with. And you can hit the table, second table, and find whatever values you want. And that's probably what they're going to ask next. So let's see what they ask next. Use the graphing to predict the number of students in the country in 2005. Well, 2005 minus 1995, and that'll be 200 minus 115 years. And I did that because you need to actually, find out what the years is since 1990. And go to x is equal to 15 on your calculator. X is equal to 15 on your calculator. I got 161.38. 161.38. And 161.38, unless they want us to move the decimal because it being in the thousands. That's it. Both of those are good test questions, so make sure you understand what we just did, okay? All right, we got one more to cover, and that's 1.213/4. Is it a test question? Let's see if it's a test question. Yeah. Excuse me, it's another calculator drill. But go ahead, and I want you to take your calculator and see if you can graph it. And if you can't, we'll just mark you down as a failure in life. So District 5 went on a protest this morning. Y'all see that? Anybody? Well, I got a lot of friends on Facebook that are on there, and they were like, Channel 4's there, Channel 7's there, Channel 21's there. I'm like, oh my God, are you worried about being on TV or are you worried about protesting? So that's the thing about these local people. They can't handle certain things. I mean, if a movie ever comes to Anderson, oh my God, they act like crazy. And then when you organize a protest, you worry about being on TV. I don't understand people. Maybe that's why I just stay on the farm. And nobody says anything. Y'all gonna make this drag out to be a long ass semester. Yeah, is that what y'all want? Just like the date. Just like the date. Now I'll have a salad and a glass of water. Boy, this date's never gonna end. Communication is the key. Y'all suck. All right. And I get nothing. Y is equal to 8 divided by x squared plus 1. Oh, man. Hold on while I uncluster this. Plus 1. Now, I know what this is going to look like because you need to add it to your family of graphs. I don't know if they've got it on there, but I'm pulling it up right now. They've got 1 over x, but they don't have 1 over x squared, so I'm going to show it to you. Add this. You might want to, there might be 1 or 2 of y'all that's already printed this out. Okay, flip it over to the back, and I want you to write this. I want you to put a graph about that size. You want to be able to put like 6 or 8 more graphs on your family of graphs. So when you flip it over on the back, just kind of break it up into 6 or 8 more graphs. And f of x is equal to 1 over x squared. This is the volcano. It looks like a volcano. So we know this looks like a volcano. So now that you got that in let's go ahead and look at it. 8, so that can be, we can rewrite this as f of x is equal to 8 times 1 over x squared. Is it plus 1? Yeah. So this 8, and we're going to talk about this 8 right here, is a magnifier, which means it's going to be compressed along the x-axis and stretched along the y-axis. And since this is not connected to the square, this right here is your vertical shift. So I know that 1 in the direction And it's going to be more toward the corner like that. So it's going to look something like that. But let's graph it and see what it looks like. And I'm going to do a zoom 6. There it is. And they don't show it. They show it going, it does go in like that. But anyway, let's go ahead and look at the options that we have. And it looks like this one. Why? Because this one's going down. This one's going down. It's not Charlie and Delta. It's not Alpha because Alpha goes below the x-axis. So it's got to be Bravo. And you feel good about yourself. Question. It says the graph has a turning point. 2 minus 1 is 1. Let me go ahead and show you that right quick. Excuse me? It has one turning point right here. I guess 0 and whatever it is, the coordinate. 0, I don't know what it is. 0 and
0 and 8.
8, be 0 and 8. I think 0, 8. Okay, so let's talk about that. Whenever you're given a polynomial, I'll give you 3 examples of polynomials. A, x squared plus 4x minus 2. B, 4x to the 5th minus 6. And C, 1/2 x third minus 2 plus 2. Okay, each one of these has a degree. This is the 2nd degree. This is a 5th degree. This is a 3rd degree. So let's write that down. 2nd degree polynomial. This is a 5th degree polynomial. And this is a 3rd degree polynomial. What else can we tell about this? Well, we can say 2 minus 1 is equal to 1, and that's how many terms we have. 5 minus 1 is equal to 4 terms. And then 3 minus 1 is equal to 2 terms. So with a polynomial, you can actually tell how many terms you're going to have by subtracting the degree 1 from the degree, and that will be how many terms you have. Again, I'm taking a question, and I'm trying to not only answer the question, but I'm trying to review a little bit for you so you remember some of the stuff. Question, right, complaint. Okay. All right, let's move on. I think that's all the questions for today. Let me check and make sure. Well, there it is. Yep, that's it. So hope that helps. If it doesn't, I'm sorry. Send me some more questions. And let's say again.
I had a quick question about number 1. The first problem you did, I typed in the same numbers that you said were like right, and it still says I got them wrong.
Okay, send me the problem right quick so I can do your problem, because you might be different. The numbers may be different. Send me your problem.
Okay, I just sent it.
Okay, I think it just came in. Let me do date. Hold on. Date. There we go. 1.211. Let me do yours. I don't know. Maybe the same. I don't know. -24, -5, 2. Okay. So I'm going to graph it now. Final check. 2 cubed is 8 plus 1. Well, wait a minute. 2 cubed is 8 plus 1 is 9. So that'll be a 9. 3 cubed is 27. 27 plus 1 is what? 28?
Okay,
Yeah.
I added it by.
I think this was a different
wrong.
problem.
I added it by. Yeah, it is.
1 cubed is 1 plus
Okay.
1 is 2. You got to watch it because sometimes the computer will switch the problem on you and you don't know it. Okay, -1 squared cubed is -1 plus 1 is 0. -2 is -8 plus 1 is -7. Y'all check me, please. -7. And -3 is -27, be -26. And that should be it. Okay, let's graph it. Cubic. And I'm going to pick -2, -9. And 0, 1. And then another one is 1 and 2. And then 2 and 9. And that should be it. Okay, let me go back and look and see what I did. Check it again. Let me clear it. 2 and 9, or I'm sorry, -2 and 7. -2, -7. 0, 1. 1, 2. And 2, 9. There we go. I must have missed a point somewhere. And it's not this one because that's Bass-Ackard's. It's not that one because that's Bass-Ackard's. And we know we got a vertical shift. I mean, we've got a vertical shift of 1. So it's got to be probably A, because this one looks like it's below the x-axis. So I would say A, or I got to blow it up to check them. Okay, does that help, Ms. Miller?
Yes, sir, it helps.
I think what happened was the computer changed it on you and you didn't catch it. All right. Now, I think we were going into 1.2. So let me look at 1.2. And, oh, yeah, lines and, okay, so, you know what? I think I got something that might help y'all. And I can find it. Hold on just a minute. And let me see if I can find it. And it'll help a lot of you because you might not be able to remember it. Let me go to my teams. And let me go to last semester. Give me a second. I'm going to have to pull this in my old class. 155, where's my 155 class? 155, 155, where is it? And there it is. And files. I believe I called it 6.6 handouts. Yeah, they are. Download. And I guess it downloaded them because I don't see them. Okay, close. Let me go back to Teams and y'all. And let me send this to y'all. I need y'all to let me know if you're getting it. So I'll tell you when I send it. Upload. Downloads. And I am fixing to send it as soon as it loads. It's about 6 or 7 sheets, but it's not like a lot of writing. There's graphs on it. Okay, I just sent it. I need somebody to let me know. Give me a nod if you received it. Anybody? Either in the conversation or in the files page. Anybody? Okay, Mr. Turner says he got it. So that means all of you got it. What is it? Well, it is a handout that I give for one of my other math classes, and it might be beneficial to you because some of you suck at it, and that is graphing. And here is the handout. And it talks about the first method of graphing, the second method of graphing, the third method of graphing, and the properties of graphing. And some of y'all probably are younger than this handout. Okay? So this is when I first started teaching. That's why I scanned onto a document, because that's how I had to save it, and that's how I saved it. So it actually goes through and shows you the 3 different methods of graphing. It shows you not only the 3 methods, but it also shows you the properties of graphing. The quadrants, how you actually plot a point, the general form of a line, of a straight line. These are called linear equations. And how to calculate the slope, and how to find the equation of a line. It also gives you vertical line and horizontal properties, as well as parallel and perpendicular. Now, what I would suggest you do with this handout for the 5 or 6 that's actually going to do it is print it out and read it. Read over it. It should knock some cobwebs loose as far as your graphing skills. But what I'm going to do is I'm going to hit the hot spots on 1.3 and 1.4. 1.3 and 1.4 does cover graphing. So I'm going to graph linear graphing. I'm going to graph y is equal to 2x minus 2. And I'm going to use method 1. And that's going to be -2, -1, 0, 1, and 2. And I'm going to plug and chug. -2 times 2 is -4, minus 2 is -6. -1 being -2 minus 2 is -4. 0 minus 2 is negative 2. 2 minus 2 is 0. And 4 minus 2 is 2. Negative 2. Negative 6. Negative 1. Negative 4. 0, negative 2. 1 and 0. And 2 and 2. So there's the first method of graphing. The second method of graphing, 2x minus 3y is equal to 6. This is called intercept method. Now, if you look on the handout that I just gave you, where I have to go find it. Hold on a second. Excuse me. I can't find my Adobe Acrobat. Where is my file? Okay, I guess it's not in here anymore. I must have, there it is. Thank you. Okay, if you notice, it tells you when you're going to graph these, is when you're going to do it. It says right here, when X and Y are not by themselves. Okay, you're going to graph using the intercept. That's what they put in the, that's what they put in the directions. Graph using X and Y intercepts. And they're not going to give you Y is equal to, it's going to be written like this. And you draw a big table. 2x minus 3y is equal to 6. 2x minus 3y is equal to 6. And I'm going to put a set of parentheses here. And a set of parentheses here. I'm going to put a 0 here. And I'm going to put a 0 here. Now, when I put 0 in for y, that's always going to give me my x-intercept. I don't care if you're in marketing, calculus, trigonometry, or biology. When you want to find the x-intercept, you plug in 0 for y. And when you want to find the y-intercept, you plug in 0 for what?
X.
Good job. Thank you for the communication. Thank you very much. Maybe I ought to start giving bonus questions or bonus points for communication. Some of y'all would still fail.
Yes, sir.
Yep. You would fail or yes, sir, to the bonus points. I'm not going to do bonus points for communicating because y'all would drive me freaking crazy about bonus points for communicating. All right. So what do? Well, you just do what you told yourself to do. Plug in 0 for y. Plug in 0 for x. Do it. I want you to do it. Plug in 0 for x and 0 for y. Now, Mr. Cavan, weren't you the one that told me you have to leave early for a class? Yes or no?
Yes, sir. I was about to say I gotta leave in like 5 minutes.
Okay, well, go ahead and put it in the chat so I can remember your name.
Okay.
But I'm going to have to leave in 5 minutes, and I'll try to remember your name. If not, the class will remind me that you were here. Okay.
All right. Thank you.
I got the answer.
And do not speed. How far are you from your class?
About 20 minutes.
Yeah, you need to go ahead and leave.
Email.
If you're going to hit Wild Hog Road, because you always get behind the little blue-haired ladies club on Wild Hog Road.
Yeah.
So you better go.
All right.
Okay.
Sounds good.
All right.
You have a good day.
You too. Good weekend. If I don't see you before, whatever. All right. So this is going to be 2x
3, 0.
minus 3 times 0. And of course, y'all all know that the 0 does what to the y term? Cancels it out, Hubert. That's right, class. 2x is equal to 6. X is equal to 3. And that 3 goes right there. And 0 for x. We know that, we know that does what to the x term? It cancels the x term out. Then you're left with negative 3y is equal to 6. Y is equal to negative 2. And that's how you do the second method of graphing. Hopefully this is knocking some cobwebs loose, yes or no? Okay, good. Again, Mr. Turner, thank you for communicating. You're going to have a nice office one day, Mr. Turner. It's going to be nice. You're going to have a big, wow, the rest of your students, colleagues, they're going to be in a janitorial closet with a piece of plywood over the desk, over the sink, because they don't communicate. All right, so the third method, I actually saw a couple of smiles. Y'all are breaking down on me. I actually saw a couple of smiles. All right, so you might have a better office if you start smiling. All right, you might not be in the janitorial closet. You know, I'll tell y'all a story. We had a new president come in, and he gave the vice president at that time a new office, and it was a closet. And eventually that vice president quit or retired. Gave a person a closet for an office. I mean, it wasn't a big room, but it was like a storage closet. And of course, that vice president retired. That's bad. All right. So anyway, third method of graphing. Third method is called building a line. And it's usually used for fractions, although you could use method 1 for fractions if you use multiples of the denominator. But in this case, all you have to do, y is equal to negative 2/3 x minus 4. And y is by itself, and your y-intercept is equal to 0, negative 4. So we pulled that out right here. And your direction of your line, slope, is left to right down. And we got that from here. And your vertical over your horizontal is equal to 2/3. And now you just plot your point. 1, 2, 3, 4. You draw a trace line. I usually do the trace line in pen so you can barely see it. I would do it in pencil if I was you. There's your trace line, which is left to right down. And then 2 up, 3 over. 2 up, 3 over. 2 down, 3 over. And then you draw your line. And that is how you draw the 3 methods. That's how you draw a line with the 3 methods of graphing. Now I'm going to jump from the 3 methods of graphing. I'm going to jump over to parallel and perpendicular. Okay? Because most of y'all know this stuff right here. Most of you, hold on, where is my, I keep losing my handouts. There we go. Most of y'all know this stuff right here. Most of you know that, you plot point 0, 0 from 0, 0. Most of you know there's 4 quadrants. Most of you know this is a general form of the line. Most of you know how to calculate the slope. And most of you know how to find an equation. Okay? So I'm going to jump to this because this is where y'all really suck. As far as students in general, these 2 questions right here are 2 properties. So since everybody sucks at that, not everybody in this class, but in the past I've found that they suck at this, I will jump there. And this is what the question will say. It will say, given um, 2x plus 4y is equal to 8. Find parallel or perpendicular to a point at 4, 5. Now it will say one of these, parallel or perpendicular. I do both because when I show students how to do both, then I'm killing 2 birds with 1 stone. So I'm going to show you how to do both. What are they asking for? Well, there's a line. This line right here is going through space, and they want to know what is the equation of the line that is parallel or perpendicular and goes through that point. I'll draw a picture of it in just a minute, but we can't draw a picture until we do the problem. So with that being said, what do you do first? Well, you draw a BA table. Now this is doing both. The homework question or the test question will ask you to do one of these. I'm going to do both. Put your equation right here. Put your point here. And put a parallel sign. And then put your point here. And do a perpendicular sign. Now, the first thing you do is solve for y. So 4y is equal to negative 2x plus 8. Divide by 4. Divide by 4. Divide by 4. Y is equal to negative 1/2 x plus 2. And m is equal to negative 1/2. So this is our indicator. Right here, this right here is our indicator. What do you mean? Well, let's go back to the rule. What does our rule say about parallel lines? What are the slopes? I'm waiting for somebody to
They're
say
equal.
They're equal. Thank you. So therefore, the slope for this line is going to be equal to -1/2. What is the slopes with perpendicular lines?
Opposite.
Opposite sign reciprocal. Opposite sign reciprocal. So that means opposite sign reciprocal means that this slope is equal to what, somebody? What's the opposite sign of negative?
Positive.
Thank you. I know that hurt, but you know, come on, you can do it. All right. What is the reciprocal of 1/2?
2.
And now you've got a point and a slope, a point and a slope. You use the point slope equation. Y minus y sub 1 equal to m times x minus x sub 1. Y minus y sub 1 is equal to m times x minus x sub 1. All right, go to it.
Priority 1 message
I'm
coming
gonna give
in
you
on
2
your
minutes.
channel.
Give you 2 minutes, and then I'll finish up before y'all start going into convulsions. And I'll give you a hint. This is x sub 1. This is y sub 1. This is x sub 1. This is y sub 1. I'm so good to y'all. You're welcome. Thank you, Hubert. You're welcome. While you're working, I'm going to pull up the handy dandy roll, and I'm going to take the roll while y'all are working. So maybe I can get finished quicker. If Tri-County hadn't logged me out. Oh my God. Tri-County, I ain't kidding you. Everybody's using smartphones. Tri-County uses a brick phone. My gosh. Log you out, 15 seconds. I'm sorry. I'm just irritated. Am I the only one, or sometimes is Tri-County like Bass Ackers? Anybody? Okay. And then they go from one extreme to the other. I got to confirm who I am so I can get into my 619838. And then they let you use Zoom all the time in classes, and Zoom is not protected by Tri-County Tech. That's what blows my mind. They do things, and then they just let some things just, what the hell? They don't care. There's no consistency. I'll shut up.
You have a work email. You have a work email.
All right, y'all are Math 109. And hopefully I can take this over to another page and take the roll. And yes. Okay, let me set the. Okay, Antley, Batson, Beltran, Brodsky. Antley, Batson, Beltran. Brody's not here today. Brody's a loser.
No, she's been on all class. She just texted me and
I thought she was here.
yeah, she's just sent me a
Thank you.
picture and it said that her internet's down.
Okay, Cavan left, but he was here. Brodsky's here. All right, let's look at Clayton is not here. Craig is here. Craig, Cruz, Hooper, Labash. Craig, Cruz, Hooper. Krakos is not here. Labash is here. Okay. Lark, Miller, Murphy, Nagayan. Lark. Okay, Merck is not here. Miller is here. Murphy and Nagayan is here. Ray is here. Rodriguez, Stevens, Terry. Rodriguez, Stevens, and Terry. And then Turner, Wallace, Wiggins. Turner, Wallace, Wiggins. And then Willie and Wilson. Okay, I got that. So let me get out of that. And I've got, okay, time's up. We'll have to do this later. So, but I'll do it real quick. Okay, let me do it real quick. So y minus 5 is equal to negative 1/2 times x minus 4. Y minus 5 is equal to negative 1/2 x plus 4 divided by 2 is 2. And then y is equal to negative 1/2 x plus 7. Y'all check me and see if y'all got plus 7. And then here, y minus 5 is equal to 2 times x minus 4. Y minus 5 is equal to 2x minus 8. And y is equal to 2x minus 8 plus 5 is negative 3. And this is the parallel line that goes through this point, and this is a perpendicular line that goes through that point. Okay, I got to go because I've got a class opening up in 5 minutes, and y'all have a good weekend. Y'all are responsible now for 1.1 through what? 1.4. You are responsible 1.1 through 1.4. So make sure you start working on that homework. Because after, if Tuesday rolls around and you don't send any questions, I'm going on to chapter 2. Y'all have a good weekend. Bye-bye.